Hello everyone, I am Girish P from Sri Venkateswara College of Engineering. I am giving the presentation on evaluate the effectiveness of PHS of an environmental friendly alternative to traditional plastics. Contents of PHS. Introduction. What are PHS? Comparing PHS to traditional plastics. Applications. Advantages of PHS. Environmental impacts of PHS. Challenges in scale up PHA production. The future of PHS. Conclusion. Now we move on the introduction of PHA. Guys, you have ever stopped to think about the impact of traditional plastic have to our environmental? It's a throw, but one of the most comfort it has we make positive changes on future generation. That's where PHS come in revolutionary new type of plastics that offers a sustainability alternative to the status. But what exactly are PHA? Well, are simply that the biodegradable polymers that are produced by microorganisms unlikely traditional plastics, which can take hundreds of years to break down. PHS can decompose it in a matter of months, leaving behind or no harmful residues. This makes the game changing for industries for really heavily of plastics such as packaging and agriculture. What are PHS? Natural plastics, degradable, flexible. Natural plastics. PHA plastics are derived from natural sources such as starch, sugars, and lipids. Degradable. Unlike the traditional plastics, PHAs are fully biodegradable and compostable. Flexible. PHA plastic can be molded into a variety of shapes from making for a versatile alternative to traditional plastics. Next, we move on the comparing PHAs to traditional plastics. Production process, environmental impact, and cost. Production process. Traditional plastics are derived from petroleum, whereas PHS can be synthesized from natural and renewable sources. Environmental impact. Traditional plastics remain in the environment for centuries, whereas PHS are biodegradable and compactable. Cost. PHS are currently more expensive to produce than traditional plastic, but this is expected to change the production scale up. Next, we move on the applications of PHS. PHA have a wide range of application across various industries including packaging, agriculture and medical devices. In the packaging industry, PHS can be used to create biodegradable bags, foods containers and even disposal criteria. In agriculture, PHS can be used to soil containers or additive in animal feed. In the medical field, PHS can be used to create biodegradable state and implant that dissolve over time. Advantages of PHS: sustainability, versatility, reducing waste. First one, sustainability. PHS are derived from natural source, biodegradable and compactable. Versatility. PHA plastics that can be molded into a variety of shapes, making them suitable alternative for a range of applications. Reducing waste. PHS can help reduce the amount of waste entering our landfill and ocean. Environmental impact of PHS. First one, sustainability future, biodegradable, compostable. First one, sustainable future. PHS can help reducing the amount of plastic wasting entering our ocean, affecting not only marine life but humans as well. Next, biodegradable. PHS are 100% biodegradable, unlike traditional plastic that harm the environment for years. Compostable. PHS can be used to make compost, improving soil health. The environmental impact of traditional plastic is significant and far-reaching. Every year, billions of pounds of plastic waste end up our ocean and landfills, where they can take hundreds of years to decompose. They not only harms wildlife and ecosystem but also contributed of climate changes through to releasing the greenhouse gases. However, there is hope for more sustainable futures for the use of PHAs. These biodegradable polymers are derived from renewable resources such as corn starch and the breakdowning naturally in the environmental without leaving harmful residual. Studies for this shows PHAs can reducing carbon emission for the 50% comparing of the traditional plastic. Next we move on the challenges in scale of PHS production. First, production cost. PHA plastics are currently more expensive to produce than traditional plastic. Infrastructure. The infrastructure for PHA production is currently limited, make it different to scale up production to meet demand. Research and development. Research is needed to improve PHA production process and bring down cost. The future of PHS. Expanding use. As PHA plastics production cost decreasing, they could replace traditional plastic in more areas reducing single-use plastic waste. Greater awareness. As awareness of the environmental benefits of PHS increases, more government and the companies may adopt their use to protect the environment. Innovation. As research and development of PHA continues, new forms and applications to bioplastic may emerge, increasing their sustainable and versatility. Conclusion. In conclusion, PHS are a promising alternative to traditional plastic due to their biodegradability and environmentally friendly properties. By using PHS instead of traditional plastics, we can help reducing the negative impact on plastic wastes in our planet. However, it's important to note there are still challenging and limited associated with their PHS to be continued and research and developing this technology. We must also work towards finding solutions for these challenges. Ultimately, it was up to all the make to conscious effort of supporting the use of PHS in the daily lives. Whether it by choosing products made from PHS to advocating their use in the communities, we all to play the role of creating a more sustainable futures. Thank you for watching.